Welcome, everybody. I'd like to thank you for joining our webinar titled Trends Shaping the FA&D Industry. I'm Hannah Toller. Today, I will be your host and moderator on behalf of PTC. In this webinar, which was created by General Brent Baker, VP of Worldwide Vertical Markets at PTC, Carsten Schaub, Senior Regional Director at PTC, Robert Hallebrand, Lead Field Application Engineer at PTC, and Peter Holler, Director of Solution Consulting at PTC. You will learn about the trends to watch out for in the coming year, managing growing software complexity in A&D products, leveraging the engineering digital thread, seamlessly integrating software and hardware development, and more. Before we jump into the presentation, let me share some ground rules with you. This is a live webinar with a live Q&A session following the presentation. The entire webinar is being recorded, and everybody will receive the recording, which will be emailed to all registrants. Feel free to post any questions during the presentation using the designated Ask Question box on the left side of your screen. We will try to answer all questions individually during the Q&A session. And with this, I'd like to pass on the word to our experts, General Baker and Carsten. The floor is yours.
Thank you.
Fantastic.
So maybe some introduction for the audience. ALM is a pretty important business for PTC. And three of the people in the call mainly come from an automotive background, Robert and Peter and myself. And now we see a kind of increasing interest in the aerospace and defense for the same kind of product. And so instead of, just having an internal discussion why this is the case, we thought it might be pretty interesting to have the same kind of discussion just publicly and to understand on where are kind of similarities between the verticals or differences, just have a kind of interesting talk between experts and why things are happening. So this is basically the reason why we have this call today. Right, General Baker? So this is the idea.
I agree. It's a great lead-in. I'm the vice president of vertical markets now, so I actually have aerospace and defense in my vertical, which I've had for about 8 years or so with PTC, and just recently automotive. But I think the thing that's really kind of shocked me is how there's a lot of similarities between the automotive industry and the aerospace and defense industry. It's not a perfect match, and there are some differences, but there's also a lot of similarities. And this explosion of software is one that maybe the automotive vertical kind of led, but we're seeing very similar things in aerospace and defense.
I mean, coming from the automotive background, more or less, so there's two interesting mega trends that really form the industry right now. So number one is what they call the software-defined vehicle, right? And the other one is everything around electrification or electrical vehicles. And basically, the race is on. The technology bets are set, and now they're going heavily in for this kind of software-defined vehicle. And by the way, maybe if you would say software-defined vehicle is an iPhone on the car, well, it's not completely true, because iPhones rarely kill people, right? So this is why I find that besides if you do a wrong step after a selfie. But basically, the kind of overlaying thing is, well, yes, we have to have a software-defined vehicle, but it also have to comply to functional safety, which is a kind of very differentiated thing about just having a kind of phone approach to a car. But if you think about software-defined vehicle, do we have some similar trend or idea in the aerospace and defense industry?
I do think it's very similar. And let me give you an example. I mean, if you look at older, I'll just use aircraft. Everybody kind of understands aircraft. But if you look at the old aircraft, there was software, but it wasn't necessarily embedded software in every major component on the weapon system, if you will. Well, today it's the exact opposite. A great example is the F-35, and most people know the F-35. I've heard not just engineers or software engineers, but I actually heard aviator pilots to say the F-35 is really a flying computer with an airplane wrapped around it. And I think there's a lot of truth to that, because it's hundreds of millions of lines of code, not just to be able to operate the aircraft, but in the helmet, all the components, the weapon systems. It's just there's a lot of software that's obviously embedded to make that aircraft function. And so I think that's very similar, where you see that like in automotive today, where it's completely changed. to what we have today. And again, it's not just the F-35, but it's a great example. This software integration is becoming so vital for safety, safety of flight. And it's also it's more important today to make the whole system, really a system of systems, be able to work together.
Yeah, it's interesting because if I take the parallel, it's somehow similar. Maybe on another. Well, let's talk about scale. So I've been visiting a conference in Berlin, which was the Software Defined Vehicle Conference, together with Peter, by the way. And we've seen an interesting a presentation by Volkswagen. I said, well, we want to have 80,000 people working on the scaled agile framework, right? I mean, this is a huge number, and so Peter and I had an after discussion. Well, what does that mean if 80,000 people work against agile? So basically, agile is the new norm by numbers, right? I mean, kind of mechanical engineers are much less, and so agile becomes the dominant method by numbers. And this has to have an implication on how a tool chain works. But let's have the first discussion. So do you see some similar scales, maybe even an extended supply chain in the aerospace and defense industries?
I think that aerospace and defense industry has probably been a little slow to this software agile integration party, if you will. But as a current trend, I see that changing significantly, and I think it's changing very rapidly for some of the reasons I talked about earlier. But the old saying is, software is eating the planet, eating the globe. I think a lot of folks, the aerospace and defense, obviously very highly regulated with a lot of standards. That's another reason. These systems are becoming more and more complex. And so you think about today, again, in the old days, you had one aircraft kind of responsible for doing its own thing. Today, that weapon system is part of a much larger enterprise of weapon systems, and they have to all be able to work together. So again, a little bit different on the aerospace and defense. I think it's more like it really kind of focuses on mission capability. But what's being done in the software, I think, is quickly happening now in aerospace and defense, and quickly expanding. And matter of fact, the other thing I would just mention, a lot of I'll just say major defense industrial base, major OEMs, major defense companies, they're looking for how to accurately and enable themselves to be able to manage this just influx of software.
Okay, so basically, I get the points. Like, I'll say, just lines of code by millions in a more collaborative way, like more parties are involved, probably in a higher change cycle over time, right? And with a lot of suppliers that have to actually give us a functional, safe product in automotive terms. So I think this is a quite similar picture, right? Peter, would you see, or Robert, would you see kind of similarity to what we do or what you do in your industries?
Absolutely, and also, like, what I wanted to highlight is that, of course, in the automotive, we are kind of living in an age when this disruption is happening, and this change is very much present. But what I also saw in my personal experience working with aerospace and defense companies, that typically they do have to operate a lot of legacy systems because they need to keep the data for much longer, and that's what's kind of kept them back or slowed them down a little bit in adapting to new technologies. But with the rapid change and the need for collaboration at scale, must initiate some sort of a change in this regard, because they have to adapt their ways at doing business and developing new products.
It's an interesting point. I mean, I'm just mentally going through the last decisions that actually where customers decided for Copimer in our ALM system. So I think one of the driving factors, because just scalability is somehow the very important one, but the other one is to be able to integrate a kind of brownfield environment, right? Because of this reason. So I see a lot of customers who
You're back. You're back.
Yeah. There's a kind of someone should tell this Wi-Fi that it has to scale better, right? Maybe I will do this. Okay. Nevertheless, like kind of so because they always want to say, well, we have a kind of a gap in our tool chain, and that needs to be filled with a product that actually is able to integrate. So General Baker is a kind of, we probably have the same kind of situation in aerospace and defense as well, right?
Right. There's really no doubt. And Peter, he gave a great, illustration. One thing in the aerospace and defense, like we do have new products, which if you're in this industry, it seems like they're happening quickly. But we have legacy aircraft that have been around for, a great example, the B-52 on the U.S. side. They'll be 100 years old. I mean, who ever thought of flying an airplane for 100 years? So we have older models and we have new models, and so you have to have this digital definition, really from the old to the new. And the other thing I quickly discovered, and I think it's similar in automotive, really no two aircraft are exactly the same. I mean, they change them, they modify them as they come out. You start out with block 10, and then it's block 20 and block 30, and it's the same aircraft, if you will, but it's a completely different capability. So this traceability from beginning to end is becoming more and more important. And when you think about like reusable software, that's been a huge challenge in aerospace and defense, because in the past we really had no way of being able to take software from an older model, if you will, and put it on a new one. And now, like with our capability with Pure Systems, and you can actually reuse software. It's a lot more traceable. And the other thing I would mention in aerospace and defense, these companies, and DoD in particular, and it's the same around the world, they try to keep up with software, but they ended up with disparate software tools, everything from a spreadsheet to the latest and greatest, and we've not really had the software capability like a Codebeamer brings to be able to manage all these different integrations, in like an understandable and scalable tool. And so it's really an exciting time.
Yeah. So, but I think you mentioned an interesting point. I mean, usually big OEMs and tier ones as well, they try to reduce or manage complexity in a kind of modular product architecture approach. And they're pretty good in doing this on the hardware side. So they've been doing that for ages, because reuse is just, like a big cost factor in your balance sheet and drives revenue and time to market and all that good things. So, but there seems to be a kind of deficit on the software side. And Robert, I think you might have experienced this in your career, right?
Yes, absolutely. That's exactly the topic we address, right, for years with Pure Variants. So by providing a solution for the systematic reuse of engineering assets on system and software side, so meaning systematic reuse of your system requirements, of your software requirements, of your respective architectures, of your test cases. When we talk about software, down to your code, of simulation assets, and so on. And you mentioned formally similarities between different industries, right? Between automotive and aerospace. To that regard, we can see some similarities as well. Yeah, so there is the need for a systematic reuse to ensure that a complex product, consisting of many components, that has a system level, a component level, is consistently configured across all these asset types, right? And you said here functional safety is a big issue here. You have to ensure that you not only somehow reuse lines of code, but you have to ensure that you also reuse the requirements along with them, as to keep the traces intact between the different assets, between requirements, test cases, so that you are sure what you are using is reused in the right way, can be reused in this context. When you reuse, you also have to think about dependencies between different things that you might be able to combine or not to combine, or that you can only use in a certain context. In military terms, I think about maybe different scenarios, so different regions where you use certain functionalities, that are not usable in another one. So you should be aware of that. And managing those dependencies and automating that reuse, helping you to identify which engineering assets you can actually reuse in that context. This is where Pure Variants is strong at, and where we have a great integration to Codebeamer, for example, to there get the right assets for a specific variant. Not only initially when you want to initially instantiate and identify what you can reuse, but also, that's the other point General Baker made, over time, right? Because these systems are in the field for a long time, and you might also want to reconfigure and to update these systems. And then you also want to have a systematic way to update a product line of many similar systems that reuse some parts of the software altogether, other parts only some of these variants reuse, right? You want to know which of my variants need which kind of update and be sure they get the right parts. So yeah.
So what you're basically saying is, well, yeah, Peter.
Just to reflect on that, also what General Baker mentioned, that understanding of the system of system design is key here, because if and as also you mentioned that as long as Excel sheets are being used to manage the right versions of the assets, which has to be configured for a given product, that is something that does not scale and requires that level of discipline that with a proper tool support could be could be eliminated in a way that the actual engineers who are best at developing new technologies could really focus on that and not keeping up with the documentation and figuring out what has happened in the past.
Interesting. So let's say if I listen to all that right, the kind of complexity drivers that we face now, maybe across industry, is, well, first of all, number of lines of code is increasing, right? Which is obvious, right? Because software, where's innovation coming from? Then we have more stakeholders that we really have to do this kind of more stakeholders producing that stuff, probably in a systems to systems approach with a more collaborative design over time. And probably with a product in mind that will live longer in the market than as of today. By the way, it's the same kind of trend in automotive. They want to have, let's say, because of sustainability reasons, it would be nice if the cars longer but still provide innovation on it. So we have a lot of complexity drivers that seem to be quite the same. And the solution might be this kind of same as well. So first of all, we have to manage complexity in the sense of, do we have our variation under control, right? And for example, do we have the change under control? That is actually happening during the whole development cycle. And the big benefit is reusing that stuff for the current and the next generation. So did I somehow summarize all the points, or did I miss something? Yeah.
No, because I was going to say, I think you summarized it, perfectly. And again, I'm often always amazed at how similar the automotive industry is to aerospace, which might be very similar to life sciences or industrial. Again, there are differences, but there are some things that are so similar. But one thing I wanted to just throw out, because I think this is very important, and this is a little U.S. centric, and I don't want to make this about the U.S. DoD, because this is a worldwide webinar. But the Department of Defense just published an instruction called 5000.97. And that, again, that may not mean a whole lot to the average person, but the bottom line is they are now directing digital engineering from requirements through visualization and all the artifacts that are tied together. Now, before it was more of a suggestion, but they're actually mandating it now for all what we call major category programs going forward. And so this integration with software has just taken like a giant leap, because it's going to be mandated now from the requirement. A lot of times we think about like it all starts with the CAD, but well before the CAD drawing is ever rendered, the requirements come in, and now it has to be a connected software and hardware capability throughout the life cycle of this product. And so that's why, like a tool like Codebeamer, because you're going to have traceability from concept all the way through retirement of this eventual weapon system. And so that has really, it's going to really change the way the industry thinks about digital transformation. And software, the way I look at it now, software is an equal, maybe even more of a demanding partner than hardware, to be quite honest.
I would totally agree. I mean, the old saying is, for every change you do in the CAD, you probably do 10 changes in the electronics part, and probably 100 changes in the software part, right? And so, I mean, if I think this is basically true, by the way. I mean, maybe even more. So, well, the kind of understanding on what kind of change impact is a kind of critical competence, right? So this is maybe this explains a little why this interest is really increasing in the Codebeamer, because this somehow leads to the point that you have to have as many data connected against a single source of truth that really can help you understand what's happening during any change or inside the whole development process, by the way. So yeah, I think that somehow explains why my phones rings all the time. Well, not my exactly. So,
well, I just wanted to jump in, and please anybody else too. But this single source of truth, Carson, the way you laid that out, it's going to be so important. And quite frankly, in the past, I call it sneaker net or human heroics. You would make a change on the product side, and you would hope to goodness that somebody on the software side, got the word, got the memo. Maybe you swivel chair to another system, and you try to input that. But there's no way with the complexity of products in general today that system is going to be sustainable. It's got to be highly connected, where you make a change on the product side, that flows to the software, or like you said, you take a change on the software, that flows to the hardware. That's going to have to be really in lockstep now. And that's the exciting thing about Codebeamer, because that's really how Codebeamer was developed, is for this high impact integration.
Agree. So, I mean, now we can be a little proud of ourselves as PTC. I would say if I look at today's portfolio of what we do, even though we are not perfect, just to make it clear to everyone in the call. So, but I think that the basic idea to have a kind of driving system with Pure that really enables you to have this product line engineering, aka having your variance under control, right? Connecting with a requirement system that actually has the test requirement and test under control. Maybe linking down to a PLM system that actually has the hardware and the modularization under control is a kind of unique value prop. And if I think, Robert, you told a story. What was the number of how one of your aerospace customers decreased time to a variant?
So there's a case study available online from Honeywell where they applied PLE and scaled agile to a product line of micro vapor cycle systems. And they were able, with product line engineering, to chip off 85% of the costs when initializing a new variant, because you can now much easier identify what you need to reuse, and also across the whole line reduce the time to market by 50% on average. So those are huge numbers. So it's not like only tiny improvements, but that really is a different way of working, of systematically reusing what's there and having then the time to focus on innovation, on making happen what's not yet developed.
But this is only the case. I mean, if you just introduce a kind one of the cornerstones of one of the portfolio things, right? Just talking about Pure. It's not even a state where we connect all the systems in a digital thread to exactly manage, or let's say control complexity, right?
But I think it's also very important to highlight that what Robert is talking about, of course, the use of a tool will bring a lot of benefits, but this is a totally different, this requires a totally different mindset and adapting to the PLE world, because still, to my surprise, many of the biggest companies in the world are just getting started with it. So they have not really established this fully. They are just exploring the possibilities here. And this goes to the next level, that establishing and having proper tool support for this enterprise-wide traceability across all domains would also should mean that we are breaking down the silos and we are creating cross-functional teams. Whenever there's a change in the software, immediately people are having access to the information in real time, and they can collaborate with one another and do not really have to go through tedious processes or trying to figure out who's responsible for what.
Yeah, that's a good point. But to the broader audience, and then I'm quite jumping. So there's huge benefits in doing so, but sometimes it might make sense to take a smaller part of it and start with something that has an immediate value. And to give you another example, it was a kind of an Asian OEM. And what they did is they actually were part of their testing procedures were done in Excel, right? Which is, well, yeah, it worked at some time, but when the complexity increased, they just were facing recalls a lot, which is bad for brand reputation, future revenue, and all that things, right? So having recalls is probably the least best option of any fault. So basically, then they say, well, let's think about trying to improve that single process about how we should manage testing in regards to requirements. So what I'm saying is, we really have to have a very educated and trustful discussion between PTC and our customer base to understand where is the immediate pain, where is the long-term pain, and how can we strategically make a difference, but generate value on the way. So, and I think we initiated the discussion with that kind of brownfield and having a stop, and this is very important to really, well, have the big picture in mind, but start somewhere, at least with some kind of recommendation that we like to give our customers, right?
Yeah. Carson, one thing again you see in the aerospace and defense industry is a lot of folks are doing, and I'll use the old air quotes, they're doing software management, but it's beyond painful. I mean, it's everything from a spreadsheet to multiple systems, probably extra hundreds and hundreds of people just trying to manage it. But like you said, there's no way in the future, especially if things as products become really complex, more embedded software, kind of everything we talked about, you're not going to be able to do that. And the thing I think about too, Robert's example, these are real savings. I mean that he kind of laid out. But if you think about automotive and aerospace and defense, the automotive industry is highly competitive. I think most folks know that. I mean, it's highly competitive. It's always changing. They're trying to kind of outpace each other on capability. So they can, have a profit. It's a little bit different on the aerospace and defense industry in some ways, but in some ways it's not, because obviously we have near peer competitors now. There's an old saying, the OODA loop, observe, orient, decide, and act. The faster you can do that, you can outpace your enemy. So think of the advantages of being able to manage your software and hardware integration. I mean, the savings are almost limitless. And I think a lot of customers are going to start seeing that today, is when they start integrating, their PLM system with their ALM system, using, new and refreshed tools like Pure Variants and Codebeamer. They're going to see, wow, there are huge advantages on being able to produce a product faster. There's huge cost savings here. And so I think this is an industry, we're really, really excited about it, because quite frankly, this has been needed in aerospace and defense. And it's kind of interesting, automotive is kind of leading the way in this regard.
Yeah. So if Hannah shows up, it seems like we have to answer some serious questions, right?
Yeah, I'm very sorry to jump in here, but I'd like to be respectful of everyone's time. And we received a few very interesting questions. The first one would be, what are the challenges of managing different defense assets and systems from varying manufacturers, and how can they be integrated effectively into a cohesive defense network while ensuring proper interoperability and interconnectivity?
Maybe I'll start and anybody else can jump in, but the short answer to that is everyone is looking for a collaborative work environment. And that's what our customers see. And again, it's not just aerospace and defense. I hear the same thing on life sciences, same thing on automotive. The idea is these consortium of companies, and it could be companies, it could be countries that are working on a single weapon system. They have to have a way to collaboratively work inside their company with other companies. And again, like I said, maybe other countries. And then they have to be able to work with their customers, hundreds of suppliers, around the globe. And so really the way you do this is by being able to have a digital transformation, digital capability. You call it digital thread, digital fabric, whatever you want to call it, really from end to end. That's what everyone is looking for. And I'm really excited to say PTC too. We're what we call a modular open system architecture company, MOSA. Used to be called Wrap and Extend. But the idea is we're able to really kind of connect all these disparate capabilities from end to end. That's what the customers are really clamoring for. We kind of hear that every day. So that's really what they're looking for.
Thank you. Another question is, what are the capabilities of critical capabilities of Codebeamer, and how does it ensure compliance with avionics standards?
Yeah, probably I'm gonna go for that one.
Go, Peter.
So Codebeamer really covers the kind of entire life cycle of in a in a holistic fashion, that from the inception of idea for systems, for different subsystems, all the way down to the source code level, different assets can be managed there, and the traceability is being built up. This covers requirement testing, risk management, and also comes with a full agile stack. But really where it shines through is that really brings the people together, the different cross-departmental teams that I referred to earlier, that we are breaking down the silos with proper integration to our PLM solution, makes it interoperable and providing a secure access to people. That's also very important, because what General Baker just mentioned, that collaboration must be established across countries and different suppliers. And best to do that in a way where proper permission layers can be introduced, and we can ensure that the right people have access to the relevant information.
All
Nicely
right.
put, Peter. Seems like you're in the industry for quite a time, right?
Hey, Peter, thank you. That's I mean, it's spot on, obviously.
Yeah.
And I would just add to that the other thing that's really interesting about Codebeamer in particular, it has a lot of templates that are already proven standard approved templates. So a great example, I'm going to refer to my notes here, but like the D0178, which is a template that's inside of Codebeamer already, that's a standard for avionics management. So, if you're a company, you don't have to do all this yourself. It's already a template in Codebeamer. And it's just like the DO326A, A202, and I know those won't mean anything, but those are templates that are already built in Codebeamer for airworthiness. So think about that. Again, you have a template that's already laid out. If you're doing airworthiness for software, that template is already built for you in Codebeamer. And again, those will continue to be built out. But that was the other thing I'll just quickly mention is PTC has always had a really great reputation for complying with standards. We're modular open system, but we're also built on standards. And so that's another way Codebeamer can really accelerate, implementation, if you will.
All right. And then another question is, what challenges do technological advancements in aviation bring regarding safety, and how are aircraft manufacturers and airlines dealing with them?
Well, again, I'll just jump in quickly. I think this is, to me, safety is the most important aspect of this entire industry, especially when you think on commercial airlines. I find it really interesting that, you think about, we all just like tomorrow, I'm going to be flying home. I'll go to Delta, I'll get on an airplane. You fly home, you're assuming the pilots, they know what they're doing, and air traffic controllers and, the aircraft. But the point is, I think it's just so important that these safety standards and this integration of hardware and software is becoming more manageable, because it does concern me that now you have a technological change on the hardware side. Did that flow to the software side and vice versa? And I just think as systems become more and more complex, that integration is going to become more and more important. And in the end, a lot of it really gets down to the bottom line, which is being able to produce a safe product, whether that's an airplane or a car. To me, it really doesn't make any difference. Both are very important, obviously.
Yeah, I mean, I think there are some recent history, well, not recent, but there were some examples in the past, like I think the Dreamliner was, where actually a software bug had stopped the whole fleet of airplanes, right? And this kind of things have the tendency to can be more because of increasing software and increasing amount of code and complexity of software. So being prepared and having this process under control, the change and the way you test that stuff is critically important. Because otherwise, you as a company just lose oversight of what's happening in your product, which is a bad thing in the commercial industry, commercial aerospace industry.
And really to get ahead of the game here is like what we hear is like automation. the more a company can automate, the more they can simulate. Continuous delivery and deployment is also key. That whenever something even properly tested, how to roll it out, and the receiving products should be prepared to be able to go live with that latest software update that could potentially fix those issues.
Yeah. Hey, I just want to use just one simple example that I wish it was mine, but it was actually Jim Heppelman's. He talks about, like, if you're in a car and you're following somebody and they slam on the brakes and you slam on the brakes, but you rear end them. His point is, well, that could have been a human error. Maybe you were following too close. He said it could be a hardware error. Maybe the anti-lock brake system didn't work. Your brake pads were bad. The calipers were rusted, or it could have been a software, the software that talks to the brake for your anti-lock. Maybe the software was out of date. Maybe there was a change. But it's a simple example. But if you think about it, that's where we are today. Everything is, it's a human, it's the hardware, and it's the software, the importance of that integration. And that's what's so exciting when you have a modern new capability like Codebeamer and Pure Variants that can do a lot of that and ensure that necessary work between those two disparate capabilities is really happening.